Good evening, Ethan. Welcome, and thank you for joining us for the software engineer position. Hi, David, Vivian. It's good to have you all here. I'm Jeannie, and I'll be chairing today's interview. We'll begin with brief introductions from the panel, and then we'll come to you. Let's start with David.
Greetings, Ethan. I'm David Wilson, the subject matter expert for this role, particularly in software engineering. I'll be discussing the technical aspects with you.
Hi, Ethan. I'm Vivian Davis. I'll be focusing on the behavioral side of the interview, how you work with others, handle challenges, and approach different situations in a professional setting.
Thank you, panel. Ethan Brooks, you may proceed with your introduction. Kindly outline your background, professional experience, and your interest in the software engineer role.
Certainly. My name is Ethan Brooks, a software engineer based in Austin, Texas. I hold a Bachelor of Science in Software Engineering from North Valley University, where I focused on data structures, algorithms, and web development. Professionally, I'm currently a software engineer at NovaForge Technologies, building full-stack features with React, Next.js, TypeScript, Node.js, Prisma, and PostgreSQL. My responsibilities include API development, testing, performance optimization, and code reviews. Previously, I worked at Pixel Stack Labs as a junior full-stack developer, where I built reusable UI components and back-end services, and at Brightscale Software as an intern, developing dashboards and learning through pair programming. I'm deeply interested in applying to this role because it emphasizes clean code, learning velocity, and the use of AI tools, all areas that match my background and interests. I'm eager to contribute and grow further by working alongside experienced engineers.
What specific TypeScript or React projects have you built that demonstrate your ability to work in a high-performance environment?
One example is an AI-powered study assistant built with Next.js and TypeScript. It generates quizzes and summaries using the OpenAI API and a retrieval augmented generation workflow. I also built DevFlow, a developer tools platform that automates project setup and documentation using AI agents. Again, built with React, Node.js, and TypeScript. These projects required careful state management, component design, and API integration, and they reflect how I approach clean, maintainable code and fast iteration in a high-performance environment.
What is your most recent project where you used AI coding assistance to improve productivity, and how did it impact your workflow?
Most recently, at NovaForge, I used Cursor and GitHub Copilot to speed up building new features and writing tests. They helped me generate boilerplate code faster and explore unfamiliar libraries more confidently. I still reviewed every line to ensure quality, but it noticeably reduced repetitive typing and context switching. It freed up more time for design decisions and improved my turnaround on small feature iterations.
When you use AI tools like Cursor or GitHub Copilot, what specific strategies do you employ to verify the generated code for security vulnerabilities and edge cases?
I treat AI-generated code as a starting point, never as production-ready by default. I manually review it line by line, check for common security issues such as injection risks, unvalidated inputs, or unsafe dependencies, and run static analysis tools where possible. For edge cases, I write targeted tests to confirm behavior, and I lean on code reviews from teammates to catch blind spots. I also compare AI suggestions against official docs and prefer well-maintained libraries with clear security histories. That combination helps me move fast without sacrificing safety or reliability.
Can you describe a specific instance where an AI tool suggested code that conflicted with your project's architectural standards? And how did you resolve the discrepancy?
Let me think for a sec. Yes. At NovaForge, while implementing a new REST API with Node and Prisma, Cursor suggested a controller that mixed business logic with database queries. Our architecture requires strict separation, so I refactored it by moving the business logic into the service layer, keeping the controller focused on request validation and response handling. I also aligned the data access with our existing Prisma patterns and updated tests to preserve behavior. That reminded me AI accelerates the work, but it doesn't replace judgment or architecture discipline.
You mentioned using Cursor for boilerplate. What is your approach to handling complex refactoring tasks where AI might miss subtle dependencies in a legacy code base?
For complex refactors, I first trace the existing flows end to end, mapping how data moves and where functions are called before changing anything. Then I refactor in small reversible steps, adding or updating tests at each stage to catch subtle dependency issues. AI helps suggest possible extractions, but I verify each dependency chain and run the full test suite repeatedly. If the system is legacy and poorly documented, I lean on targeted logging and peer reviews to avoid breaking hidden assumptions. It's slower than copy-pasting suggestions, but far safer and more maintainable long-term.
When you use AI for generating unit tests, do you prefer writing them from scratch or using tools like Jest's coverage to identify gaps first?
I prefer starting with coverage reports, like Jest coverage, to see what's missing. Then I use AI to scaffold the basic test cases, but I review and adjust them carefully. AI tends to miss domain-specific edge cases, so manual thinking is still crucial. Coverage tools help ensure breadth, while human judgment ensures relevance and correctness. The blend gives me solid test suites without blind trust in generated code.
In your Next.js projects, how do you decide when to use server-side rendering versus static generation for API-heavy endpoints?
Let me think for a second. For mostly static content, I'd use static generation for best performance, possibly with incremental regeneration. For user-specific or fast-changing data, I lean towards server-side rendering, ensuring fresh data per request. I also balance client fetching with React Query for live interactions after the initial page load, so the UI stays responsive without overfetching. Ultimately, it's a trade-off between performance and freshness, and the choice depends on how dynamic the data needs to be.
When debugging race conditions in your Node.js services, what specific logging strategies do you implement before relying on AI suggestions?
I start by reproducing the issue reliably, then add detailed logging around async boundaries to trace timing and shared state access. I'll simplify the code path by isolating the critical section and using controlled delays to observe behavior. Only after I understand the pattern do I consult AI for refactoring ideas. That order helps prevent blindly applying changes that might mask the real concurrency issue.
Since you mentioned leveraging AI coding assistance to improve productivity in your summary, can you describe a specific instance where using an AI tool helped you solve a complex problem or significantly speed up development?
A clear example was building a new REST endpoint at NovaForge. I used Cursor to scaffold the controller and service files, then refactored the generated code to match our layered architecture. It saved significant setup time, but I still manually reviewed dependencies and added tests. It cut hours off boilerplate work, while keeping me accountable for correctness and alignment with our team's standards and design patterns.
That sounds efficient. When you manually reviewed those dependencies, did you encounter any edge cases or security concerns that the AI missed? How do you ensure your final implementation is robust enough for production?
Checking. Yes. At NovaForge, the AI suggested code with insufficient input validation and overly generic error handling. I tightened validation, sanitized error responses, and verified Prisma queries against our architecture patterns. For edge cases, I tested missing inputs, non-existent records, and unexpected database failures with code unit and integration tests. I don't treat AI output as production ready by default. It always goes through our code review, security checks, and testing standards. That combination keeps the final implementation robust enough for production.
That's a great example of maintaining quality. If you were working on a high priority feature with a tight deadline and found yourself stuck in an infinite loop of AI suggestions that weren't quite right, what specific steps would you take to break out of it?
First, I'd stop prompting the AI and restate the problem in my own words. Then diagram the current flow and mark exactly where the behavior deviates. Next, implement the smallest possible manual fix, backed by logging and tests, before asking AI again. If pressure is high, I'll focus on correctness first, optimization second, and communicate trade-offs to the team so expectations match reality. That way, I don't waste time chasing endless AI variants and keep progress steady.
That's a solid strategy for maintaining focus. If you were collaborating with another developer who strongly disagreed with your approach to using an AI tool, how would you handle that disagreement while still meeting the project deadline?
I'd start by listening carefully to their concerns. Then, suggest a quick experiment or side-by-side comparison to evaluate both approaches without turning it into a debate. If time's tight, we pick the option that best aligns with project standards and deadline, document the trade-off, and revisit later. Keeping the discussion respectful and evidence-based helps the team move forward without unnecessary friction or quality loss.
You mentioned documenting trade-offs. Can you give me a specific example of a time when your documentation helped another developer understand an architectural decision that initially seemed counterintuitive?
Let me check for a specific case. At NovaForge, we were adding a back-end feature, and a newer developer questioned why we were moving business logic out of the controller into a service layer. I documented the reasoning in our implementation notes, explaining how the separation improved testability and long-term flexibility, with a simple diagram and example. A few weeks later, when we needed another endpoint that reused those same rules, it was straightforward, and that same developer told me the documentation made it click. That reinforced for me that explaining the why, not just the what, really helps maintain consistency across the code base.
That's a great example of proactive communication. If you had to explain a similar architectural trade-off using an AI tool like Cursor or Claude Code, how would you ensure your explanation remains clear and accurate without introducing hallucinations?
I treat the AI's explanation as a rough draft only. I verify each claim against our actual code, architecture docs, and test results. I avoid copying unverified details and annotate the explanation with references to specific modules or commits so others can check. If something is uncertain, I say so explicitly. The goal is transparent reasoning that teammates can validate, rather than a persuasive but ungrounded narrative.
How do you handle it when an AI tool suggests a solution that conflicts with your team's established coding standards or best practices?
I treat the AI suggestion as a proposal, not a decision. I compare it against our team's coding standards and architecture guidelines, and bring it to the code review for discussion if there's a mismatch. If it violates a principle, for example, layering or security, we reject or modify it, then document why we chose our approach. Keeping that explanation clear helps align the team and avoid confusion on future contributions.
Can you describe a specific time when your documentation or code review process helped prevent a similar conflict before it reached production?
Checking. Yes. At NovaForge, a code review caught a change that put business logic into the controller, conflicting with our layered pattern. I referenced our implementation guide and included a brief example showing reuse of the existing service layer instead, which helped the developer adjust the approach before merge. It prevented inconsistent patterns from landing in the codebase and later made it easier to extend the same business rules to another endpoint without duplication. That experience reinforced that clear documentation and code reviews are most effective when they explain the reasoning, not just enforce a rule.
What specific steps do you take to ensure your team stays aligned with those coding standards as new members join or existing ones evolve?
We onboard new members with a short architectural walkthrough and examples of preferred patterns. We keep living documentation and run regular code review calibrations to align expectations. When standards change, we broadcast concise updates, update examples, and invite questions so everyone understands the rationale, not just the rule. That helps keep decisions consistent as the team evolves.
How do you handle a situation where an urgent production fix requires temporarily bypassing one of your established coding standards?
In a real incident, I'd make the minimal safe change to restore service. Document exactly what was bypassed and why. Then create a follow-up task to reintroduce the standard properly once the emergency passes. I communicate clearly to stakeholders that it's a temporary deviation, so the urgency doesn't turn into a long-term maintenance problem.